Hello, welcome to the webinar, Writing a Successful Anton 2 Proposal, which is in preparation for the request for proposals for Anton 2 that we are opening at the Pittsburgh Supercomputing Center. So this webinar will be presented from 2:30 to approximately 3:30, and then at 3:30, Desres will present a webinar on enhanced techniques, enhanced sampling techniques, which are Anton 2 capabilities, which are useful also to know to plan your research strategy on Anton 2. So my name is Marcela Madrid, and I am a scientific specialist at the Pittsburgh Supercomputing Center, and I'm here with Phil Blood and Rosita Lagai, also from the PSC. And from Desres, we have Ken Mackenzie right now. So I will get started. During this webinar, I will explain Anton 2 capabilities and how you can apply for computer time in order to write a successful proposal, as I said. Anton 2 is a special supercomputer for specialized in molecular dynamics, which for systems that are biological systems, and it has to have periodic boundary conditions in order to be able to simulate on Anton. It was designed and constructed by D. Shaw Desres and is hosted at the PSC. And it's made available without cost by Desres for non-commercial use by US research institutions and other not-for-profit institutions. International collaborators are welcome, but the PI needs to be from a US institution. As I said, it is hosted at the PSC with support from the NIH. And what Anton 2 does is it dramatically increases the speed of molecular dynamic simulations. And so it allows researchers to reach scales of milliseconds. And therefore, it can fundamentally change the kind of questions that can be asked from a molecular dynamic simulation. The proposals, therefore, should focus on those applications that require very long trajectories of several microseconds long, for example. More information can be found at the psc.edu/resources/Anton page. And there you will also find this lecture and the recording and a survey, which Rosita will put the link to the survey. And we ask that you please fill it out before finishing the webinar, because it is very important for us to get feedback. Something went wrong. Anton 2 enables breakthrough science because in just 9 machine days of Anton of simulations, which is the maximum yearly allocation per research group, a research group is able to produce results that would take years of continuous runtime on any other resource, reaching timescales of tens to hundreds of microseconds, as I said. And it is applied for to problems in biomolecular research, such as nucleic acids, lipids, proteins, nanostructures, force field development, because it allows you to test force fields and also applications in artificial intelligence because in the analysis of very long trajectories that can then be fed into AI methods. Now, who can benefit from running on Anton 2? Researchers who need long time scale approaching milliseconds or hundreds of microseconds long molecular dynamic simulations of biological systems, as I said, nucleic acids, proteins, lipids, in water and with periodic boundary conditions. And in order to run on Anton 2, you would write a competitive proposal, which I will describe next. And the request for proposals is now open. And the deadline to submit the proposal is January 29th. And we ask that you start the process of submitting the proposal a couple of days before, because you need to create an account at PSC.
Sorry, Marcelo, that's June. I guess everyone sees it, but June 29th. For the,
yeah. Did I say wrong?
You said January. That's okay.
June 29, 2023. And so the request for proposals can be seen at this URL. Where you will find all the details on what is needed and how to submit. If the proposal is successful, you are given an allocation of time, which is for 1 year. So what are the tips for a successful proposal? First, you would need to explain how Anton 2 will achieve breakthrough scientific results. Using Anton 2 will help your group achieve breakthroughs, scientific results that cannot be achieved in any other supercomputer. And second, you will make sure your system meets the technical requirements to run on Anton 2. Which I will explain next, and provide all the requested information that is described in the RFP. If you have any doubts, you can contact PSC at anton-support@psc.edu or grants@psc.edu. Those are the two emails where you can send your questions. And also, you are welcome to interrupt at any moment if there are any questions today. So how can Anton 2 help you achieve scientific objectives? To maximize the benefit of Anton 2, the proposed simulation should focus on problems that will be greatly advanced by the unique capabilities of Anton 2, which usually it means very long trajectories, and it has to be a biological system. And explain how achieving these scientific objectives requires the use of Anton and cannot be achieved by any other high-performance system or GPUs. It's important to specify in your proposal the need for longer MD trajectories that are not feasible on conventional systems, and the application that requires long time scales, which means approaching millisecond long MD simulations. As I said, the RFP can be located here. And the deadline is June 29th. And the PI for the proposal must be a faculty or staff member at a US academic or nonprofit research institution. A grad student or postdoctoral researcher may not be a PI, but a qualified advisor may apply on their behalf. Each investigator can serve as a PI for only one application in a given allocation round. And this is important. It's important not to duplicate applications, in the sense if there is a PI and if there is a co-PI, and then the same pair applies as PI and co-PI in another proposal, it is important to demonstrate that the two branches are distinct and independent and do not constitute an effective doubling of the allocation for one of them. And demonstrate that the Anton work will happen primarily in the lab of the PI and will be directly supervised by that PI. So in other words, there can be a PI on one proposal with a co-PI and reverse for another proposal, reverse the roles of co-PI and PI, but it's important to show that the branches are independent and not just a duplication, a scheme to duplicate the allocation. We encourage applications for PIs that have not any previous experience using Anton, and 25% of the total allocation time is reserved for these PIs that have not had previous experience. And so they are encouraged to apply. The chemical system and the force fields that can be simulated on Anton 2 should fulfill these conditions. As I said, they have to have periodic boundary conditions in explicit solvent. It has to be, the simulation cell can have only right angles. That is a cubic or orthorhombic box. And it has a minimum of 45 angstroms dimension on each side. There is a minimum and a maximum number of atoms. For Anton 2 is between 25,000 and 700,000 atoms, including the solvent. Although there is a range that is recommended for maximum efficiency, which is between 50,000 and 600,000 atoms. The system should consist of protein, DNA, RNA, lipids, water, and standard ions. And so the proposed simulation must use one of the standard non-polarizable biomolecular force fields, such as CHARM or AMBER, or there are modifications that have been published by DESRES. But check the RFP for the details on the force fields. And then the water also should be modeled by the standard models. The next webinar that starts at 3:30 will talk about enhanced sampling capabilities. So in a lot more detail. And you will need, after this webinar is over, you will need another Zoom link to connect to the next webinar, and it will be presented by DESRES. So the simulations can have a uniform constant electric field applied, and it can have position restraints. And the enhanced sampling is available in 4 forms, which are simulated tempering, restraints between the center of masses, restraints to a reference structure, and tempered binding. And it is the variables for the application of restraints between the center of mass and the RMSD, which is with respect to the reference structure. The equilibrium and the spring constants can be varied during the simulation according to a schedule or adaptively to implement a form of umbrella sampling. If your system does not fall exactly within the ones that I have explained, in the sense that you have custom parameters or molecules that do not include force fields that are in the standard distribution of the supported force fields, or if you have dozens of restraints or restraints involving thousands of atoms, or the dimension of the simulation cell is much larger in one direction than in others, we ask that you contact us by email to check on the feasibility of the project. In the proposal, you also will need to estimate for the proposal the amount of simulation time to ask for. And so in the RFP, we provide a table which consists of the number of atoms and the performance in microseconds per machine day. And so from this table, you can extrapolate according to the number of atoms of your system, how many machine days it will take per microsecond of simulation. For example, if your system consists of 116,650 atoms, it will take 21.9 microseconds per machine day. And it's important to know, by definition, there are 50,550 MD simulation units per machine day. And so from there, I show here how you can extrapolate how many simulation units you would need. And the maximum that can be requested is 460,000 MD simulation units, which is a simulation unit is the amount of machine time required to simulate 1 nanosecond for 50,000 atoms with Anton production parameters. This is explained in the RFP. And then you would convert the simulation units to machine days. The maximum that can be requested is then 9.1 machine days. And it's important to show these calculations in your proposal. So you would estimate how many machine days you would need, and it's important to show how did you reach these numbers? How many? How do you? I mean, explain your reasoning behind your request. And there are 2 levels that you are encouraged to apply to target. 10 to 20 allocations are made every year at or near 460,000 MD simulation units, which is the maximum. And then there are 30 to 40 allocations at half that. So you might want to target one of these 2. The proposal should have between 2 and 6 pages in length, not including the references which are not counted. If the API has already had an allocation, then it is mandatory to have a progress report, which of 2 pages maximum, demonstrating the success that in using Anton to produce high-impact scientific results. And then you can submit up to 2 additional supporting documents, which can be, for example, published papers in PDF format on the submission page. The proposal, however, despite the fact that you can submit additional supporting documents, the proposal needs to be self-contained because the reviewers are not required to refer to these other documents or any other external documents when reviewing the proposal. And grantsmanship is important, how the proposal itself is written. The proposal is divided into 6 sections. The first one is the summary, with the title of the proposal and other information. It has to be 400 words maximum for the summary. Then the name and address, email, and telephone number of the principal investigator and the copy-eyes. 1 page maximum for the background information, which is the scientific information. And then the scientific objectives, which is 2 pages maximum, explaining why Anton is necessary for the planned project, why the project could not be efficiently completed on any other high-performance computer, and the scientific impact of the proposed project. There is a 5th section that is mandatory to include in the proposal, which is the project feasibility and team qualifications. And under project feasibility, we mean that the proposed system fulfills the conditions that we are outlining in the RFP, which are the simulations must be standard MV in constant NVE, constant MPE, or constant MVT. The simulation cell must have only right angles. The simulations should propose to use a force field that is supported. The number of atoms is between what Anton 2 can handle. And the simulation should not be short. It should not finish in less than 1 hour on Anton, for example. We look for simulations that benefit from Anton capabilities, take advantage of the Anton capability of running long trajectories. It is important to have the system already built and equilibrated by the time the allocation starts, so that you can take advantage of the 1 year during which you can run on Anton 2. So if state in the proposal whether the system has already been built and equilibrated. By equilibrated, we mean running several nanoseconds in another supercomputer using standard software such as NAMD, Amber, GROMACS, Desmond. And then we will provide the tools to convert that trajectory to the Anton trajectory. If you don't have the system already equilibrated, please provide evidence that it can be successfully built and simulated. Describe the expertise and experience of the research to ensure that the simulations will be successful. And as I mentioned, if there is a copy on the proposal, provide information demonstrating that the work described in the proposal will be conducted primarily in the PI's lab and will be supervised by the PI. Clearly state and provide justification for the number of Anton MD simulations, and provide strong scientific arguments as to why the length and the number of proposed simulation runs will be both sufficient and necessary to achieve the stated scientific objectives. As I said, if the PI has had a previous allocation, include a progress report as a separate document, and is mandatory for groups that have had an allocation before. It should be a maximum of 2 pages. Describe how the previous allocation was used and summarize findings of results. And the results can be discussed in the context of publications, but all the information should be clear in the progress report itself. That is, the progress report should be self-contained. Explain if there have been any changes from the original proposed resource or any delays for some reason. describe, in that case, the reason for underutilization of the previous allocation. Now, what are the common proposal pitfalls? Poor grantsmanship is probably #1 issue, which is a lack of it could include a lack of clear hypothesis, lack of explanation about why the system you are studying is important, or what contribution the results will have on the field. We look for projects that will produce breakthrough science, because Anton 2 is a breakthrough enabling supercomputer. Another pitfall could be the insufficient explanation of the roles of PI and co-PI, insufficient justification of the number of requested simulation units, of the need for Anton over standard supercomputing clusters or GPUs, a weak explanation of the progress since the last received allocation. Remember I said if there are reasons for underutilization, you can explain them in the progress report. And insufficient justification for unused prior Anton 2 allocation, which means that if your proposal is successful and you get an allocation, plan to start running as soon as possible, which allocations start in December, so that you can fully take advantage of the resource. And then after all that preparation, you go to the portal and submit the proposal. This is explained at this URL, which is the psc.edu/resources/Anton RFP. And once we receive the proposal, it is first reviewed internally at PSC for feasibility, and whether there are missing documents. We would contact you to try to have everything in order to submit to the review panel, which is convened by the National Academy of Sciences. And the process is rigorous and transparent, and the review committee is made public. And there is a community comment period prior to the review. The entire committee must agree on the recommendation report, which is then made public. And then you would be notified of acceptance, and you will receive information about how to log in to Anton and to get started. And we offer a workshop on how to get started running on Anton 2 in the beginning of December every year. So after the review, expect a notice of proposal acceptance by mid-November, and the full report by the National Academy is published on their website. The allocation, as I said, is for 1 year, with an extra year to access the files. And we offer this Getting Started workshop in the beginning of December. This is a 1-day training workshop with hands-on, with PSC and DESRES instructors. And most people who attend this workshop finish the workshop running their own systems on Anton. We ask that you acknowledge Anton 2 in all publications resulting from your work, and that you let us know that your publication has been accepted, because we keep a database with all the publications and PhD thesis resulting from your work on Anton 2. So please don't forget, this is very important. It is important also for you for future renewals. Also, the trajectories generated on Anton 2, we collect them for a database that we are constructing. So all trajectories generated on Anton and their associated data is kept private until publication. Once you have published or 1 year after your allocation on Anton has ended, whichever comes first, we collect the trajectories and we plan to make them public in a database that can then be used for further research or educational purposes. The slides for this presentation and the RFP are at this URL that I have mentioned before, and please fill out the survey. Rosita has put the link on the chat also. And so I wish you all best of luck with your proposal. Are there any questions that
Hi, can I ask?
Sure.
Yeah, hi, I'm from India. So actually, I can't directly apply, so I have to contact a PI who is from US, right? So
Yeah.
for these applications, like while we were discussing, is it required that you also need some experimental validation of your proposal, or only simulations will do? Like you need in the later part, do you is it required that you include some experimental validation, or only a computational proposal will do? That's my question.
Yes, it's only a computational proposal.
So no need to add any experimental validation of your this thing, right? Proposal?
Correct.
Okay, thank you.
It's entirely a computational resource. Now, by the moment you publish, you may want to include validation, experimental validation. I'm not sure. I mean, is it that your system is such that it needs experimental?
Most of the publications now, they require some experimental validation, and as I
Yeah.
understand that these are very competitive proposals, so many times if you don't have a validation, they don't consider your proposals. So that's what I wanted to know. Like if I submit, should I also include another co-PI who is an experimentalist, or only computational people will do? That's
Only computational will do, yes.
okay. Thank you.
Let me just add, Marcella, that that there's so just to be clear that there's no requirement that you have an experimental collaborator, but depending on what you're proposing, I mean, clearly you'd like to provide whatever evidence you can that will convince the review panel of the feasibility and the impact of the work that you're proposing. So those things certainly won't hurt, and will help you if you can provide those things, but it's not the proposal will be considered whether or not you have them.
Okay, thank you.
Yeah, so yeah, it's not required. If you feel that it will strengthen your proposal, you can include it. Are there any other questions? If there are no other questions,
I
please.
have a question.
Okay.
Yeah,
So
if everybody who is awarded gets to start using it in December, and the
yes.
machine can only process a certain amount at a time, is everybody put in a queue at the very beginning?
Yes, the way it works is by a queue system, but it's usually not busy at all in the very first months of the allocations, and it becomes very busy towards the end.
Okay.
So is this to your advantage to begin as soon as possible?
And the directions to convert from, like, my systems are being used in Amber, to convert it into yours Is that a relatively quick thing?
We tried, yes, unless your system is very complicated, but we provide help. We will personally help with the conversion if it is too difficult for some reason. And there are documentation online with step-step instructions. And also during the workshop in December, you can bring your own system and work on that conversion, and you leave the workshop already with your system converted.
So that workshop is before the allocation time actually begins?
A few weeks after. I think it starts December 1st and the workshops are usually December 10th.
Okay. And are the directions to convert available now, for example?
They are password protected.
Oh, okay.
But there are step-by-step instructions. But we could help you convert now, but it wouldn't make any sense because you cannot access Anton.
Okay.
What kind of system do you have?
It's going to be about 600,000 atoms. It's proteins embedded in a membrane.
Yeah.
With water and ions.
Yeah.
They're all standard molecules, though.
Yeah, it should be standard conversion.
Okay.
Yeah. I was going to say if you can please fill out the survey, and I will be happy to answer any other questions.
I was just going to put in another plug for starting early. If when you're successful, like Marcella said, it's not super busy at the beginning. So if you get ahead of the curve, you even get some extra time sometimes if the machine's not busy. You can actually get a little bit of extra time if you've used up your allocated time. You can run in a deferred mode and actually extend your allocation a bit. So we try everything we can to encourage people to simulate early to alleviate the log jam that happens when everyone's allocation times are about to expire. All right, anyone else have questions? Any behind the scenes or anything that wasn't quite clear?
Then we will connect again with a different link for the enhanced sampling webinar.
Okay.
Right.
As Marcella mentioned, we have a new link for the second webinar. And so please make sure to just use the new link. And yeah, please also fill the survey, and it will help us a lot to just make this webinar more successful for next time. Thank you very much. So I will stop recording if everyone is okay with it. Yeah.
Bye.